Hello, am I audible?
Yes, sir.
Okay, alright, yeah. Yes, so good evening to all of you.
Evening, sir.
Yeah, just general thing. How many of you covered the lectures of week 8, or at least you have covered three videos, at least 3 to 4 videos.
That Jay's rule is remaining. Otherwise, everything is done.
Okay, all right. So only 2 or 3 of you have covered, right? 4 people. So what about us? You are ready to start, right? Okay. Okay, one thing, city session is about to finish, or still it will take some time. Anyone? Any idea? Yes, no. Nothing.
It's going on.
Okay. Okay, then let's wait for some. Should we wait or should we start? If that is okay, then we can start. So mainly agenda for the today's session, I will just quickly summarize the content of week 8 along with examples related to every topics. Okay, I think I'm hoping that will be all right for everyone.
Yes, sir.
Okay, so yeah, I will start from 8:10. Let's wait for some 3 to 4 minutes and then we'll start.
Sir, hello.
Uh, okay, so let me start this session. Yes, Pranov, and do you any query?
Yes, actually, it is related to extra activity which is due by tonight. So, in the video which has been shared, in that it is referring to create the Google site using registered email ID, which is by the I think which have the domain of IIT Madras, but we haven't received that. So my question is, can I do this particular extra activity with my current registered email ID, which is from Gmail?
Yes, I will tell you, but I think you have missed one statement there. So those who, like, suppose you don't have, the student, I mean, this IATM domain ID, then
Yeah.
there is one more video you should refer it. Okay, so I think this is the term portal. Let me open qualifier one.
Okay.
So there is another video we have created. So how to, create that portfolio with using your so like this. So there is one more video. This refer this video. So if you will refer this video, just click here. Okay,
Yes.
it will redirected to
One
one,
more time video.
yeah, one more video. So
Okay.
here once, so without your this IATM mail ID. So whatever you make sure you are going to use the registered mail ID.
With which I have registered
But
for this
here,
particular course.
yes, yes, yes.
Okay. Okay.
Okay, so you can see this video. We have discussed how to create that part. Okay, without using
Okay.
ITM.
Okay.
Okay,
Thank you, sir.
yeah. So yes, Isika.
And I had one more doubt from the extra activity only.
Uh-huh.
There in the video that Andrew sir said they published for IIT members only, but in
See,
the
that's
note
why.
said
Okay,
like
okay. That okay. The video which I told you, just see that it will be clear where you to publish. Okay, that video is specifically where for those who do not have IATM in mail ID. Okay.
okay, okay.
Yeah. Okay. So Khushi, do you any queries?
Yes, sir.
Yeah.
So, since we don't have an IITM domain email ID, so how are we supposed to do peer review?
It will be automatically updated on your, uh, dashboard. So just wait for the till 12 p.m. I think today is the due date. After that, you will get at least three activities of some random student. Okay.
Okay, sir.
So all the backend algorithm is there. There is no need to worry about like this. Okay. Okay. Yes, Isika.
Hello, sir.
Yes.
Sir, I have a question. Like, if I have data of names, right? There is name and all name are different. There is nothing common in them. How do we? What kind of graph we draw for them?
So for name, no, no. For name, I don't think there is something. Uh, see, for particularly name, I don't think graph will be appropriate for this. You can like draw the graph for, let's say, for like how many people are from, let's say, some any particular part of India. Let's say how many are people are from, east part, west parts, north part, south part. For that you can plot, pie chart. Let's say 30% are, I mean, in your data set whatever you have, let's say 30% are from north and 40 from south, some 20 from east and something like that. Okay. So for name, I think there will not be any appropriate.
Yeah, and for student ID also it's not possible, right?
No, it depends
But
how you are going to do. Like, see, for student ID and all.
yeah, all the IDs are unique for
Yeah,
each
yeah.
student, so it's
Okay.
not possible.
So that's what the question. You have to think how to, do the visual representation of it.
But sir,
Okay.
name itself is a variable, right? So, what do we write in the place where we have to show that we have drawn a plot for this also?
Actually, for student ID, I just leave this space by that.
So
I
just
don't think so.
okay.
There's any
So
suitable for.
we have given one, example to you, right? One sample solution for that extra activity. Okay. Just
Yes,
do
sir, but
according to that.
there is nothing like names. There is gender, which is
That's why. Okay,
categorical,
okay.
and
Okay. So I will give you the answer right now. Uh, Okay, so you have to think accordingly. Okay. See, name and all, I can give you a hint if you are going to plot a name. Suppose you are going to get each bar for a name, right? So that doesn't seem, meaningful, right? Means you are
yes,
getting for individual people a graph. So something like that. So, okay, suppose I told you that example, right? Regional wise distribution. Then you can have some idea, regarding how many are from science background, like how many are from, arts background, something like that. So it will depends on your data, how you are going to represent the data. So that's the case in your extra activity. You have to identify and what okay, if there is not possible any visual representation, then you can mention why it's not like this, or you can simply mention because of this reason there is no meaning of some this visual representation. Okay, something like that.
okay, sir.
Yeah, yeah. So let me share my screen. I'm going to start the session. Okay, so in week 8, okay, so we will start like we will see. I mean, agenda is we will start with the conditional probability. My voice is clear to all of you, right? Do let me know
Yes,
if
sir.
in between there is
Yes,
any,
it's clear, sir.
disturbance or any issues there. Then after conditional probability, we will move to the part what is the multiplication rule. Okay. After multiplication rule, we'll see what is the independence. Okay. So we will see some, like definition and all for every topics, independence of events and all. Then we will see after multiplication rule and independence, we will see some properties related to independence of events. Then we will see law of total probability. Okay. Then we will move to final, which is called Bayes theorem. So these all topics, are very important for learning point of view as well as exam point of view. So whenever you will move in stage 2 course or in further courses, so actually probability is one of the I mean probability will play a key role in part of data science and statistics itself. So let's try to understand what is this conditional probability. Okay. So as of now, we saw addition rule of probability without any condition at all. So in conditional probability, what's happening there? Okay. So let me write. So in conditional probability, what is happening there actually? So in conditional probability, you will be having some prior information that outcome of the random experiment. Let's say there are two set A and set B. For example, there are two set A and set B, and you have some prior information that outcome of the random experiment must be in a set of B. Okay. Suppose you have sample space, and this sample space, for this sample space you have two set A, set B, or let's say event A, event B, and you have some prior information. Outcome of the random experiment is already in B. Okay. Then we will be interesting if outcomes of the random experiment is already in B, then what will be the probability that occurring in event A, right? I mean, what will be the probability of the occurring of the event A? Okay. So we will see before moving to the final formula. I will create one contingency table which you have seen already in V4, and will try to understand the uh, concepts of this conditional probability. So maybe you have seen that ownership of a smartphone. Okay. and you had one thing, another variable was gender. This was female, male. Okay, no, yes. So let's say this is 0.10. This was 0.34. This was 0.14. This was 0.42. Okay. So what is the total here? So it will be 0.44, right? And this will be 0.56, and this will be 0.24, and this will be 0.76. Okay. So what is the grand total? Grand total will be how much? 1, right? So you can see the probability of all the things is 1. Okay. So what is the like what kind of things we can extract from here? Suppose I will ask what is the probability of female, then what will be your answer? 0.44,
0.42.
right? So because for female we are interested in this row, right? Basically we have to take this one plus this, right? Basically what is this? I mean, this is something we'll see a bit later also, but let me clarify. So what is the probability of female? So basically what we are doing, probability of, what is this part? Can I say female and let's say, let me represent O complement means non-ownership of phone. Can I say this female and O complement plus, can I say female intersection of O?
Yes,
So
sir.
basically, that is happening with this part. Okay. What about if I will say probability of no, mean not ownership of a phone? So it will be 0.10
Point.
plus 0.14. That is nothing but 0.24. Okay. Now, if we'll move to the conditional probability. Okay. So conditional probability. Suppose I'm saying among let's say all female buyers, the chance that someone owns a smartphone. Okay, so what I'm saying, among all the female buyers. Okay, so I'm interested. What is the chance? So you can say what is the chance or probability? Someone own a smartphone. Okay, so what is the condition here? Anyone can tell me what is the condition here? Suppose total candidate is 100, then it will be 10. Okay, let me draw again. This is female, this is male, this is no, this is n. Yes, so it will be 10, it will be 34, right? And then 14 and 42. Okay.
It
So
will
this is
depend upon
40.
the gender. That's what you want to say.
1 second. Yeah. Okay. So what is my question? Question is, among all the female buyers, what is the chance that someone own a smartphone? So what is the condition here?
The buyer is a female.
Buyer is a female, right? Okay. So what is the condition here? So I know what is my new sample space will be here. Rather than 100, I'm interested only in this part. In total
Yes.
44. Yes or no?
Yes, sir.
Yes, sir.
Right. I'm saying among all the female buyers, that means I'm interested among this all 44.
Yes, sir.
Okay.
Yes, sir.
Now my question is, what is the chance that someone own a smartphone, and what is the probability? Favorable case divided by total case. So if by using this condition, so this will be my total case, right?
Yes, sir.
See, in general, this is the total case, but I'm considering this as a, you can say, new total case or total case one, something like that with the different name. So thing is that I have put in one condition. Now, what is the favorable case?
34.
So this will be your probability.
Yes, sir.
Yes or no? Right. So this is something you can do, or else, okay, can I do something like this? If I'm interested to know among all the female buyers, okay, suppose can I write like this? 34 divided by 100 divided by 44 divided by 100.
Yes, sir. This is the same thing.
Yes, sir.
This is the same thing. Okay.
Yes.
You can go with the probability part also. So this is the conditional probability formula. I will let you know what is the formula. Okay. Before that, just give me some answers. Okay. What if I will say among all the like males, what is the probability that the chance that someone do not own a phone? So
Sir,
what is
14 by
14
56.
by
14 by
56.
56.
14 by 56 because I'm
56.
interested is I have given among all the males. So now my new sample space will be this one,
56. Yes, sir.
right? So what is suppose I'm saying what is the probability, or let's say I'm saying you to consider let's among all the buyers, what is the probability that a selected candidate is a female?
34 by
44 by
76.
100.
44 by 100.
44 by 100.
Among all the
Thir-
buyers,
34 by 76.
correct.
34 by 76.
So I'm interested in only who own the phone, right? Who purchased the phone already, right?
Yes, yes, sir. I got
Okay.
it.
Yes, sir.
Understood? So this some sort of rough idea is okay? Yes, no?
Yes, sir. Yes, sir.
Okay,
Yes,
now
sir. Yes, sir.
I will come to the original formula of conditional probability. So this is something we just try to understand the intuition behind it. Okay. So suppose I'm saying I have two event E and F. Okay. So conditional probability says the probability that event E occurs, okay, given that event F occurs, okay, means event F is already occurs, or you can say so will is given by. So what is the condition? Why we are saying conditional probability? Because there is a one condition. It is already given that F event already occurred, right? Okay. So formula is okay. I will come to formula a bit later. Let me try to. Okay. Suppose this is E. This is F. Okay. And this is your whole sample space. Now what I'm saying, among these two events, this event F is already occurred. That means this red region is already occurred. Yes or no?
Yes.
Right. If F is already occurred, so now my new sample space will be this F.
Yes,
Yes,
sir.
sir.
Do you agree with me? So okay. So this is can I say number of events occurring in this F or not?
Yes, sir.
See, probability is what? Probability is nothing but favorable cases divided by
Total cases.
total cases, right?
Right, sir.
Now, what I'm saying, F is already occurred. So now my new total cases, or you can say new sample space will be number of events in F. I mean number
Yes,
of
sir.
elements in F. Yes or no? Now, what is the probability that I'm saying F is already occurred? What will the probability that occurrence of E? Now, what will be your favorable case for among this red region? What is the probability of occurrence of E?
E intersection F.
Sir, E intersection F.
Right? There is only one possibility. This part.
Yes.
Yes, sir.
Right? So can I say number of elements of occurrence of E intersection F?
Yes,
Yes
sir.
or no?
Yes, sir.
Right? So can I write like this? N E intersection means number of elements. So can I write like this? N of S divided by N of F divided by N of S? Yes or no?
Yes,
Yes,
sir.
sir.
This
Yes,
total
sir.
element. So can I write like this? Probability of E intersection F divided by probability of F.
Yes, sir.
Yes,
Yes,
sir.
sir.
This is clear for the algorithm behind the formula.
Yes, sir.
Okay, is it clear to all of you, right?
Yes, sir.
Okay. So similarly, if I can write probability intersection, sorry, push different color here. So what we got, probability E is I mean, given that F is already occurred, nothing but probability of E intersection F divided by probability of F. Now, if I will write probability of, suppose, just going to change the scenario a bit. So probability of F given E, that means what? Probability of E intersection F again and divide by probability of E.
Yes, sir.
Okay. So there is one condition, this probability of F should be greater than 0. Okay. And probability of E should be greater. Only this formula will be, meaning. Is this all right?
Meaningful, yes, sir.
Yes, sir.
Okay. Any doubt in this formula?
No, sir.
No. Okay. So let me come with some, uh, open. I think in activity, which activity include the yeah, condition. Let's try to do one. Let's try to do one problem from here. Let's say I'm interested to do this last. Okay. Suppose two dice are rolled. Okay. What is the conditional probability that at least one of the die lands on 5, given that their sum is 11? So let's define the events like this. First of all, let's define event E. Okay. So activity 8.2, question 4. Let me define event T that like this. At least one dice lands on 5, right? I can, so this is given that. So I can define F as a sum is 11. Yes or no? Their sum is 11.
Yes, sir.
So question is we have to calculate probability that E given F, right? This is the question. First of all, to calculate this part, so I need intersection part divide by probability of F.
Probability of F, yes, sir.
Now, what is the, first of all, let's try to understand what is the probability of F. So what is the F? For F, what will be number of elements for F? Their sum is 11.
2,
6, 5,
5, 6.
5, 6. So that means probability of F is what? 2 by 36.
Yes, sir.
Right? What is the number of outcomes in for the event T?
It should be all 5.
Depends for quiz
11.
2 syllabus for, okay, so one more thing, yeah. So I think we have sent one announcement for stats 1 course only. Syllabus for quiz 2 will be 5 to 8. For other course, I think it's a 1 to 8. You can confirm with the
Sir,
respective instructors. Yes.
when we got one mail today, sir, which
Hmm.
it is from IITM only. It did not say any subject, but it said that it did not say any subject name. It just said that from week 1 to week 8.
See, I
So does
think
it
you are
apply to
again
all subjects?
mistaken. I told you, did you check the course code?
Course, yes, sir. Course on I checked. In that it's
Yeah,
week
so
5 to 8.
it's that means it's for, they are talking about for that particular subject. Okay.
Okay, sir.
There will be
Yeah.
a course code, bro.
Yes. So based on course code you can do. So for stats, I'm just clarifying. Do not worry. So syllabus is 5 to 8. Okay.
Okay, sir.
Yeah. Okay. So what is the number of elements in number of elements for the event? At least one die lands on 5 means what? It will be 5 1, 5 2,
6.
up to 5 6, and
Yes.
then
1,5.
1 comma 5, 2 comma 5, 3 comma 5,
6,5.
4 comma 5, 5 comma 5, and 6 comma 5.
Yes, sir.
I think that's all, right?
Yeah.
But what is the common between E intersection F for E intersection F?
6,5 and 5,6.
5 comma 6 and 6 comma 5, right?
Yes, sir.
Now, what is the probability for this E intersection F will be 2 by 36?
Yeah, sir.
Well, correct. So what will the now we got this numerator part 2 by 36. We got this denominator part which is again 2 by 36. So here probability is 1. Okay. So it can vary, but like you got the idea, right? What we have to do first? We have to, uh, first we have to calculate intersection part. then we have to calculate this marginal part, and then we can go with the division part. So basically, if you come to this part, right, this question here, okay. So if you, I can give you the condition. Let's say, what is the probability that, again, suppose I'm saying among all the female buyers, suppose what is the probability that female is given to you, right? What is the probability that they are ownership of a phone? Let's say let's say they doesn't own a phone, right? So let's say I'm talking about O complement. So what we have to do according to formula, O complement intersection F divided by probability of F. Yes or no?
Yes, sir.
So what is the probability for O complement intersection F?
Hmm.
Basically, this will be, what is the probability for O intersection?
10
This
by 44.
10 by
10.
44.
Okay, I'm talking about this part only. So can I write 10 by 100?
Oh, yes.
44 divided by 100? It will be
Yes.
10 by 44. Right? So you can do directly also. That's not a problem. Just I was explaining what is the meaning of this numerator part and denominator. Okay.
Yes, sir.
Now is it okay? Is it clear? Should we do one more
Yes, sir.
example with this? Let's do this part. Okay? First question. A game club has 80 members, out of whom 70 plays chess, 45 plays table tennis, and 35 plays both chess and table tennis. Okay. So out of, among 80 members, so total is 80 members, right? Activity 8.2, question 1. So what is the total
Sir,
number of this is? Yes,
so that mail regarding the syllabus says that it's week 1 to week 8 for foundation registered students.
I told you, right, from which course ID you got.
So from our normal, from our own ID.
No, there will be a course ID.
Okay, so that course ID is MA1001. Okay, so they are talking about foundational courses and re-attempt qualifier. They didn't mention the math part actually by mistake, but it's for math. Okay.
Yes, sir.
Okay. So I'm going to clarify for stats. It's the 5 to 8 only. Okay.
Okay, sir.
Yeah.
In the
Okay. So
podcast,
total is 80. And how many chess? So 70 play chess, 45
And
play table
45
tennis.
tennis.
So let's say E who play chess. Okay.
Yes, sir.
Okay.
70.
F as table tennis.
Yeah.
Okay. So this is 70. This is
40.
45.
45.
And 35 plays both,
Both.
right? So E both means E intersection F. This is
In,
4500, right? So
yes, sir.
question is, what is the probability if a member of the club is chosen randomly? Conditional probability that he or she plays the table tennis, given that he or she plays chess. Okay? So whenever you are going to solve the questions related to conditional probability, be little bit careful. Okay, so you can define like this. So this is your E. After given that, this is your event
F.
F, right? So probability that E given F, and the formula we know, probability of E intersection F divided by probability of F. Now, what is the probability of E intersection F? First of all, what will the
Sir,
probability of E
it's
intersection?
35. You have written it as 45.
Okay, yeah.
35 upon 80.
Yeah. Okay, sorry. So this is 35. So what is the probability of E intersection F will be?
35 upon 80.
35.
35 divided by 80. I'm talking about probability, not numbers. Okay.
Oh,
And
yes.
what is the probability of F?
45
45
80.
upon 80.
45 by 80.
Okay. And this question is for chess, right? Condition is chess, right? Yeah.
Conditional probability that
No. We have to do in reverse order. No one corrected. So it's a F given E, right? Yes or no? If you see, the play table tennis given that play chess. So chess will be under condition, right? So it will be probability of E. Now is it fine?
yes,
Yes,
sir.
sir.
Sir, upper
Okay.
वाला को change कीजिए.
So probability of E will be here 70 by 80. This is probability of F. So what is the numerator part?
See, numerator part is not going to change. Whether you are writing E intersection F, F intersection C, meaning is same, right?
Oh, yes, sorry.
What is the denominator part? 70 divided by 80. 80 will
80.
get cancelled out. So 35 divided by 70, which is
2.
half.
Sorry, half.
What if I will write probability of E intersection F? So this will be probability of, sorry, E given F. Probability of E intersection F divided by probability of F. So what is the intersection probability for intersection part?
35 by
35
80.
divided by 80, and probability of F is 45 divided by 80. So
45
80 will
by
get
80.
cancelled out. So 35 divided by 45. So
So
7 by 9
by 9.
is your answer. Okay. Okay. This part is okay. Conditional probability part is okay to all of you.
Sir, your voice is not coming properly.
Is it? Is it for everyone or?
Fine, it's
Oh,
fine
sir,
now.
now it's good.
Okay. So now this conditional probability is fine to all of you.
Yes, sir.
Yes, sir.
Okay. All right. So let me come to another concept. Next concept, which is called multiplication rule. Okay. So what is the multiplication rule actually? So now we have seen conditional probability formula, probability of E given F equal to probability of E intersection F divided by probability of F, right? Can I write like this? If I will write, can I multiply this probability of two left hand sides? What I will get? Probability of E intersection F into probability of F or not?
Yes, sir, we can get.
And one more thing, make sure just keep in mind this probability of F should be greater than 0. Now, if this is the case, can I write this probability of E intersection F equal to probability of E given F into probability of F, or
Yes, sir, we can write.
or let's write like this. That's also correct. Probability of F into probability of E given F. Yes or no?
Yes, sir.
One more thing. This is the case. If for this case, if I will do in reverse, if I will write like this, probability of F given E, what should I write? Probability of E intersection F divided by probability of E, right?
Yes,
So
sir.
Yes,
can
sir.
I, what I can write here, from here, can I get probability of E intersection F is nothing but probability of E into probability of F given E?
Yes, sir.
Yes, sir.
Okay. Actually, this thing or these things known as the, multiplication rule of probability. Okay. This is nothing but known as multiplication rule. Okay. And you have seen, uh, addition rule. What was the addition rule? Addition rule of probability, anyone? In week 7 we have seen. Anyone can recall?
For the
P
joint
of
probability, we add their probabilities.
I'm
No, it
talking
will be
what is
probability of E plus probability of F plus probability of E intersection F. Minus.
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 Okay.
Yes. So actually, addition rule is probability of E union F is nothing but probability of E plus probability of F minus probability of E intersection F. Okay. So sometimes people get confusion between these two, but addition rule is for union part and multiplication rule is this. Okay. So this multiplication rule is nothing but just like you can get from conditional probability formula itself. Okay. So I will take one
Sir,
example. Yes.
sir, your voice is dropping sometimes by talking.
Is it? I think
Yes, sir.
it's
Sir, sometimes it feels like you are very far from the microphone.
Yes, sir.
not like that. Now is it fine?
Yeah, no,
It's
it is
fine,
fine.
sir.
Okay, okay. Maybe in between there is some issue, but do let me know whenever there is anything. Okay. So let me take example from multiplication rule. Let's come with this part itself. Okay. So question says a box contains 8 white balls and 4 black balls. Okay. So activity 8.3 question 1. So there is a box which contains 8 white ball and 4 black ball. Then 2 balls are drawn at random, one after the other without replacement. Okay, we are not putting back in the box. Find the probability that both the balls drawn are black. So thing is that, so suppose let me define the event. Let's say I'm saying event even is, so whenever you are going to solve the questions related to probability, right, try to define the events appropriately. So even will be, so what is the main question? We have to find the probability that both balls are drawn are black, right? So let's say I'm saying probability even I'm going to define as a first ball is black. Can I define? And what is the probability? So let's say E2, I can define second ball is black. Would you agree with me?
Yes, sir.
Yes,
Now,
sir.
Yes, sir.
what is the question? Question is probability that both balls drawn are black, right? Both means I'm talking about E1 and E2, right? First is black and second is also black. Yes or no?
Yes, sir.
Yes.
So
Yes,
can
sir.
I write like this? It is talking about without replacement and all. So can I write like this? Suppose I have drawn first ball is black into, can I write? You have drawn first ball, right? There is one condition because you are doing without replacement. What is the probability of U2? Sorry, E2. Yes or no? So what
Yes.
is the probability that first ball is black?
4 upon 12.
4 by
4
12.
upon. Now,
12 upon
condition is
12.
even is already there. Means first ball is black already. What is the probability that second is black?
3 by 11.
3 by
3
12.
by 11.
3 by
11.
11.
Yes, sir.
This
11.
condition is there, right? So if you will solve this, 4, 3,
1 by 3.
no, 1 by 11.
1 by 11.
Yes, sir. 1 by 3.
Okay, you
4
can
by
do in
12.
reverse order also. Okay, because I told you, right, this multiplication rule, you can do like this: probability of F into probability of E given F, or probability of E into probability of F given E. Let's do in reverse order also. So if do in with the second approach, so it will be probability of E2 into
Intersection.
probability that E1 given E2. Yes or no?
Yes, sir.
Right. So what is the probability of E2? Means second one is black, something like that. So it will be 4 by 12. Yes or no? See, anyway, you will get the same answer. That's not a problem. Here, E2 means one ball is already the which you have drawn is black. So what is about second one? It's a 3 by 11. Okay. So thing is that what I'm trying to explain here. So you can use any one, any formula for this. You will, because both are the same. Is this clear?
Sir, if replacement was allowed, it would be 4 by 12 into 4 by 12, right?
Yeah. Then it 4 by 12 into 4 by 12. Yes.
Sir, sorry, 4 by 12 into 4 by 11.
No,
It is replaced now, so it will be 4 by 12 again.
yeah,
Okay.
it will be again 4 by 12. So because it's a repeating. Okay. So you can, okay, suppose I will talk like this. What is the probability that first ball is black and second is white when with replacement is there? Then you will do 8 by 12, right?
Yes, sir.
If I will say first is black without replacement, second is white, then it will be 8 by 11. Okay. So it will change according to the scenario.
Sir, if we are saying replacement, so it means that we are putting the ball again back.
Correct. Again in the box.
Yes, sir.
Okay.
See, if it is a case of not first and not second, just two balls, one is white and one is black.
Then you
What
will
happens?
do combination. You can do with the like you can do,
Oh,
let's say
take
you
two.
have
Take two at a time. I mean, yeah.
correct. So I can do
Okay.
4 C2 divide by 12 C2.
Okay.
Okay, because here we are worrying about the order. Let's say first is
Yeah,
black,
yeah, yeah.
second is white. If you will do combination, then
Yeah.
this case will be also considered, right?
Yes,
In
yes,
any way,
yes.
we have one black, one white, one white, one black. So
Yeah.
you will do let's say 4C1 into 8C1 divided by 12C2. Got it?
Okay.
Yeah,
Okay.
that's the difference. Yeah. Okay, just give me a second. Let me connect my laptop with charging point. Okay, I will Hello, am I audible, right?
Yes, sir.
Yes.
Yes, sir.
Yeah, let's try to do one more question with this. Yeah. Let's try to do this one, right? Because it's talking about putting back again, right, in the box. Okay, we'll get the some now. So consider that you have a box with 5 blue marbles, 3 red marbles, and four yellow marbles. You are going to pull out one marble, record its color, and put back in the box and draw another marble. Okay, what is the probability of pulling out a blue followed by a yellow marble? Okay, so question is in a box. Okay, so in a box, so this is question number 3. In that box, 5 are blue marbles, 3 are red marbles, 4 are yellow marbles, right? So you have to basically we are drawing. So what is the condition? A blue marble followed by a yellow marble, right? That means first should be blue, right? Yes or no? Let's say even. Even I'm going to define event even is first marble is yellow, right? Then E2 will be second is blue. Yes or no?
Yes, sir.
Okay. So what we have to find basically? So probability of E1 into probability of given that E1 into E2. Yes or no? Because blue marble followed by yellow marble. So first of all, you have drawn one yellow marble, then blue marble. Yes or no?
Yes, sir.
Okay. What is the probability of E1?
5 by 12.
5 by 12.
5 by 12. Very good. And what is the probability of E2 given E1?
4 by 12.
4 by 12. By 12 because we are putting back again in the box, right?
Yeah, because it is replacement.
Correct. So just solve this, you will get the answer for this question. Okay, so let's try. So 4, 3. Yeah. So 5 by 36 should be the answer. Let's see. Yeah, 5 by 36 is the answer. Okay, is this clear? This rough idea is okay to all of you? Yes,
Yes,
no?
sir.
Okay.
Yes, sir.
Sir, even is for yellow marble.
Even if?
Even.
Yeah, even is for yellow marble. Yes.
So it should be 4 by 12.
No. Okay, one second.
So the
Maybe
answer is correct, but the thing is,
one second. I think. Oh, sorry. It's the blue marble followed by yellow marble. Ah, sorry.
the answer
So
is going to be same, sir.
yeah, answer is going to be
Yeah.
same. It should be blue. Actually, I wrote in reverse order. Sorry about that. Yeah. Now it's clear, right? So
Yes,
for
sir.
blue, it's a 5 by 12, and for yellow, given that, yeah, correct.
Sir, I have a
Thanks for.
question in it.
Mhm.
Sir, how to apply the formula? Like how to know that this formula is going to be used in here?
Yeah, that will come along with the practice.
Okay, sir.
Yeah. So thing is that you have to just be clear with this. See, in multiplication rule, you have to calculate this part, right? This intersection part. I'm going to next part. Just do the next part, which is about independence events. If independence is not there, then you can go with this part. Sorry, this multiplication rule. Okay. So conditional probability is clear, right? In conditional probability, we will be having this intersection part and this marginal part. But in multiplication rule, this conditional will be given to us, marginal will be given to us. We have to go for this intersection. Okay. Okay. So next is it clear, right? Next topic is called independent event. Okay. So let's try to understand the meaning of this independent events. Okay, so I will. Okay, so two events. Let's say two events. No, events E and B are said to be independent if when you can see two events are independent, if okay, just let me write if the happening, or after that I will come up with the mathematical notation. If the happening or non-happening of, you know, any one of we have two events, right? Any one of E and F, or you can say any one of them. So them means I'm talking about E and F. I mean doesn't if affect the happening of others. Okay, doesn't affect the others. Okay, now what is the meaning of this? So if suppose I'm saying E is happening, then what should I write for non-happening of event E? E complement.
Yes,
Yes, sir.
sir.
Happening for F and non-happening for F, F complement.
Yes,
Right,
sir.
that is the meaning, right? E is there, E is not there. F is there, F is not there. Correct? Hello?
Correct, sir.
So what is the question? The happening or non-happening of any of the event doesn't affect the happening of others. So what is the meaning of this? What I'm trying to say means, suppose probability of E given F equal to probability of E given F complement. This will be same as probability of E. Now is it clear? With the, are you able to relate with the statement? Means happening of F or non-happening of F doesn't affect the happening of event E. Yes or
Yes.
no?
Yes, sir.
Can I can write in the reverse order also. Probability of F given E equal to probability of F given E complement equal to probability of F, means happening or non-happening of event doesn't affect the happening of event F. Are you getting?
Yes, sir.
Okay, all right.
Yes,
Now,
sir.
I mean, this will be disjoint, no, in that case.
no, disjoint is different thing. I will come
Because
to
if
that point.
if event one is not connected with, then only it can impact that different.
I will come to that point, Ajay Kumar. I will differentiate between disjoint and this independent. Okay, people have confusion for those two. I will come up with the come for that. Okay. Now this rough idea is okay. What is the actually meaning of independence? Means I mean they are not associated. Means happening or non-happening doesn't affect the happening of the other event. Right. Right. That is the meaning of independence. Right. Yes. No.
Yes, sir.
Okay, let me come to this formula, actually mathematical formula which we are using. So probability of E given F, what should I write for this? For conditional probability formula, what is the normal formula?
E
Probability of
intersection
Intersection.
F by probability of F.
very good. Now can I write from here probability of E given F into probability of F equal to probability of E intersection F?
Yes, sir.
Now can I write probability of E intersection F equal to probability of uh, E given F into probability of F? Yes or no?
Yes, sir.
Now, what I'm saying, suppose E and F are independent. If E and F are independent, then this probability of E given F will be equal to probability of E or not? By this one. So I'm saying E and F are independent, then probability of E given F will be equal to probability of E.
Yes, sir.
Right? So can I write this as a probability of E, this part only, and we have probability of F? Yes, no?
Yes,
Yes, sir.
sir.
Now is it clear? So this is the basic thing when if I'm saying two events E and F are independent, if probability of E intersection F is same as probability of E into probability of F. Is this clear now? So this is the
Yes, sir.
definition of independence. So this formula we got from this user. Okay. Now come to disjoint part actually. So when we are saying two events are disjoint or mutually exclusive,
Intersection is equals to phi.
this is disjoint or mutually exclusive if E intersection F is phi, right?
Yes.
If you will take the probability on both sides, so probability of E intersection will be probability of phi. What is the probability of phi?
There is no common element between them.
Probability of phi. Probability
Zero,
of phi
sir.
means null
Zero.
event, that is zero.
I think so, 0.
So probability of E intersection F is what? You will get 0, right?
Yes, sir.
Yes, sir.
So this will happen when your two events are disjoint, and this is when your two events are independent. So in case of independence, probability of E intersection F is same as probability of into probability of F, and probability of E intersection F in case of disjoint will be 0.
Sir, it means that in case of disjoint, there is no like similar element in
Nothing,
intersection.
nothing.
Yes,
So
sir.
disjoint means there is nothing common in those two,
Yes, sir.
events. Okay. All right. Is this fine?
Yes,
Yes,
sir.
sir.
Okay. Now,
Yes, sir.
one more thing which we are using again and again. I will quickly go through that. I'm not sure whether I should do the derivation part. Let me give you a basic idea. So there is one something you can keep in mind.
Your voice is weak.
Now is it fine?
Yeah.
Yes.
Yeah, might be there is some. Suppose I'm saying if A and B are independent. Okay. So events can be anything, A and B or E and F. I'm just taking a different notation so that you will be used to it. Then there is something called, then you will say first part A and B complement are independent. And so what is the meaning of A and B complement are independent? I will say probability of A intersection B complement, it should be equal to probability of A into probability of B complement, right?
Yes, sir.
Because when I'm saying A and B are independent, probability of A intersection B should be equal to probability of A into probability of B.
D.
Yes or no?
Yes, sir.
Right?
Yes, sir.
I will prove this one. Don't worry. So I'm just going to write these things. So I will say A intersection and B are independent. Okay. So what is meaning of this? Suppose probability of A intersection, sorry, not in A complement intersection B equal to probability of A complement into probability of B. Right? This is the meaning of independence. Right? Third, I will say A complement and B complement are independent. So this means probability of A complement intersection B complement, this will be equal to probability of A complement into probability of B complement. So why this is important? Whenever suppose some case is there and you have been asked you to find the probability of A complement intersection B. If you know these two are independent, then you will multiply probability of A complement and I mean they are actually respective individual probability. Okay. So do you want to do me the derivation part or no?
Yes.
Yes. Okay. Okay. Let me do it. Okay. So what is the probability of A intersection B complement? How should I write this? First of all, suppose this is Venn diagram. I'm going to draw Venn diagram. Suppose this is A and this one is D. So what is the B complement actually? This part? Yes or no?
Yes, sir.
Right? And what is the A intersection B complement? A intersection B complement means this green one.
Only A.
Right? That is the intersection part of A and B complement, right?
Yes.
Yes or no?
Yes, sir.
Right? So how can I write this one as a what should I write from this Venn diagram? How I will get this, green part? If this is probability of A, this will be A. This which one
P
I'm
of
going to
A
highlight?
minus P of B.
Okay. P of A minus P of A intersection B. If I will subtract this, intersection part, I will get the green one, yes or no?
Yes,
Out
sir.
of this total, if I'm going to subtract this, intersection part, dotted region, I will get the green one.
Yes.
Right now. So what is this probability of A minus, and I know probability of A and B are independent. So what can I write? I can write probability of A into probability of B. Yes or no? This is given to us.
Yes.
Right?
Yeah.
Yes.
If this is the case, I can take probability of A common. I will get 1 minus probability of B.
Yes, sir.
Yes,
Right?
sir.
And what is the
B
probability
complement.
of B?
Which is B complement.
B complement, right? So now, is this verified?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
Now, let's do the second part. Probability of A complement intersection B. Now, if you will draw the Venn diagram, suppose this is A, this one is B. So what is the A complement? A complement, this shaded region, right? Blue one, right?
Sir.
Right? What is the intersection with
An
B?
observation?
B, sorry?
Can I make an observation?
Yes.
In the last derivation, probability of A intersection B complement, if the B is independent of A, B complement is also independent of A.
Yes.
So A intersection anything is equal to PA into P of that thing.
Correct. So that's what we are just trying to prove with the mathematically. That's all. Okay.
Intuitively, that makes sense.
Yeah.
It should.
So actually, this is the basic definition of independence, right? Happening or non-happening of any one of them doesn't affect the happening of others, right?
So if B is B is independent, B complement is also independent.
Also independent, yes. So we were just trying to prove with mathematics.
The same thing applies to the current one. When what we are trying, A complement is also independent of B.
Correct.
It will come to the same.
Yeah.
You
It
can
will
go
come to
through
the
that just to keep
correct.
another way.
So what should I write here? Now, this green region is our interested one, right? How would I get this green region?
Probability of B minus.
Probability of B minus.
Probability of A intersection B, right? Yes or no? If this is the B part, if I will subtract out of
Probability
B,
of B minus. Yes, sir.
this intersection, I will get the green one, right?
Yes, sir.
And we have already information A and B are independent. I will say probability of A into probability of B. So probability of B I can take common. I will get 1 minus probability of A. So it will be probability of B into probability of A complement. Now this correct?
Yes, sir.
No. Okay. Let's do the third one also. Probability of A complement intersection of B complement. Okay. There is. Okay. What should I write? This A complement intersection B complement. Can I write A union B? A union B whole complement?
Yes.
Yes or no?
Right.
I can write this one or not?
Yes.
Sir.
Yes, sir.
Right? If this is the case, so you can draw the Venn diagram. So now can I write probability of A union B whole complement as 1 minus probability of A union B?
Yes, sir.
Yes, sir.
Now, what is the case for A union B? Can I write probability of A with the addition rule, probability of B minus probability of A intersection B?
Yes, sir.
Yes, sir.
Now we have information A and B are independent. Then this will be probability of A into probability of B.
Yes.
So I can write minus P of A minus P of B. This minus minus will be plus. So I can write P of A into P of B.
Yes,
Yes or
sir.
no?
Yes, sir.
Now, if you see a bit So what should I write here? I can write, this part 1 minus probability of B minus probability of A plus probability of A into probability of B. Just, this I took here. So this will be 1 minus probability of B. If I will take probability of A as a common, I will get 1 minus probability of B or not? From
Yes,
here, if
sir.
I will take probability of A
Yes,
common,
sir.
what
Yes,
I got
sir.
from here? 1 minus P of A into 1 minus P of B. So
Yes,
what
sir.
is this? Probability of A complement into probability of B complement. So just keep in mind, if A and B are independent, then A complement and B are also independent. A and B complement will be independent. A complement and B complement will also be independent. Then you can
Independent.
keep these all things in your mind. Okay.
Yes, sir.
Okay.
Sir, after
So
class, will you send us the PDF in the chat box?
yeah, anyway, we'll upload on the portal as well. Okay. So
Send
there
on
is
the
some,
chat box.
yeah. Okay. There is something called similar to this. This is called pairwise independent event. Okay. So what is the pairwise independent events basically? So see, if you have set of events, let's say A1, A2, AN. Okay. Let's say A1, A2, AN. So what do you mean by pairwise? I'm talking about a pair, right? So this I will say two pairs AI and AJ, let's say, will be independent if and only if probability of AI intersection AJ, this is same as probability of AI into probability of AJ, right? This I will not be same as J, correct? So this is same as which we have seen for independence of two events. Now is this clear? Are you getting my idea? So what is the key thing is here? Suppose you have three events. Let's say A1, A2, A3. I will say A1, A2, A3 are pairwise independent. When I will say these three are pairwise independent if and only if, can you tell me, can I write probability of A1 intersection A2? This is same as probability of A1 into probability of A2. Yes or no?
Yes, sir.
Probability of A1 intersection A3 equal to probability of A1 into probability of A3, right? Probability of A2 intersection A3 equal to probability of A2 into probability of A3. So this all cases are satisfied, then you will say these three events are pairwise independent. Okay.
Pairwise. Yes, sir.
So far it is clear. Okay. So now if you have three events, this A1, A2 and A3, then you will say these three events are independent. So for this, why this is in importance, I will, this is called pairwise independence. So if you have three events, right, then to check the independence of these three events, they should be, there should be pairwise independence as well as intersection of these three, A1 intersection, probability of A1 intersection A2 intersection A3 should be equal to product of their marginal. So what I mean by this, so they should be, this part actually, let me write itself. Okay. So probability of A1 intersection A3 should be equal to, let's write to A2, probability of A1 into probability of A2, probability of A1 intersection A3 equal to probability of A1 into probability of A3, probability of A2 intersection A3. This is same as probability of A2 into probability of A3. Along with this, probability of A1 intersection A2 intersection A3, then it will be probability of A1 into probability of A2 into probability of A3. If this is the case, you will say A1, A2, A3 are independent.
Independent.
Okay. Is this clear?
Yes, sir.
Okay. Clear to all of you? This fine. This is this rough idea is okay behind this.
Yes, sir.
Okay. All right. Yeah. So, okay, suppose question is, you have been given some, let's say A and B. Question is, you have been asked, you have to check whether these two are independent, independent or not. Then what you will do? You will just simply check intersection part. whether intersection part of these two are equal to product of their marginals or not. So this is the case you have to check. Okay.
Okay, sir.
Okay. Are you getting this idea? Everyone is getting this idea?
Yes, sir. We have to check probability of A and B.
Yes, you have to check intersection of those two, whether intersection of those two is equal to product of their marginals or okay. Let me take one example. Suppose uh, let's say I'm saying take up cards. Okay? Let's say I'm saying take up cards. Say example of take up cards. To like to check how to check this independence, then I will take one example where we are going to use this independence. Let's say I'm saying there is an event, I'm saying let's say A1, which will denote a face card is selected. Okay. Now I'm going to
Yes,
take
sir.
A2. Let's say a king is selected. Again, I'm going to take E3 as let's say a heart is selected. Okay. I mean, from a normal deck of 52 cards. What is the probability? Okay, question is whether A1, A1 and A2 are independent, or A2 and A3 are independent or not. So question is A1 and A2 are independent. This is question. And A2 and A3 are independent. So this question we have to verify. So to check the independence, what is the key thing when I will say A1 and A2 are independent? Probability of A1 intersection A2 should be equal to probability of A1 into probability of A2.
Yes, sir.
Yes or no?
Yes, sir. This is same.
To check the independence of this, I have to use probability of A2 intersection A3 should be equal to probability of A2 into probability of
A3.
Very good. Now, tell me what is the probability of A1 here? A face card is there. How many face card is there?
Sir,
12,
12
right?
by
52.
52.
12
Yeah,
by 52.
52.
What is the probability of A2?
A king
4
is
by
selected,
52.
sir.
4 by
4 by
52.
Yeah, there are
52.
4 king, right? Uh, what
Yes.
is
So
the
there are
probability
4
of
kings.
A3?
A heart is selected,
13 by 52.
13 by 52.
13 by 52.
Very good. Now, what is the probability of A1 intersection A2? Means what is A1? A face card and a king.
Probability of 12 by 52 into
No,
4
no,
by
I'm not
52.
saying you are using the
4 by
independence.
52.
This is we have to check.
Oh,
This not apply. You have to check this.
sorry, sir.
What is the meaning of this? Means a face card and a king.
Yes,
It
common.
will be 4 by 52. So that means they are not independent.
Okay, everyone is agree why this 4 by 52 is coming?
Yes,
How
sir.
many face
Because
card? Yeah,
in
one second.
face
How
card,
many?
king is also there.
Correct. How many face card is there total? 12, right? But
Yes,
among the face card, king is also face card, right?
yes, sir.
So that
Yes,
means
sir.
we are talking about 4 by 52, right? Now,
Yes, sir.
what is the probability of A1? 12 by 52, and
Yes.
probability of A2, we have 4 by 52, right? So we
Yes.
have to check. So whether this probability of A1 intersection A2, okay, what is this 4 by 52? This is same as 12 by 52 or into 4 by 52 or not?
No.
No, right? That means what? What we got, probability of A1 intersection A2 is not equal to probability of A1 into probability of A2. Yes or no?
Yes, sir.
Yes, sir.
That means what? I will say A1 and
Not
A2
independent.
are
Not
not
independent.
okay.
Not
Let's
independent. Yes.
let's try for this. What is the intersection part? What is probability of A2 intersection A3? Means probability of a king intersection a heart. Tell me what will the probability for this?
1 by 13.
1 by
1 by 52.
1 by
1 by
52.
52. Total is
Oh,
52.
52.
Alright. What is the probability of A2 into probability of A3? So probability of A2 was 4 by 52, right? A3 is 13 by 52, right? I'm taking
Yes,
from
sir.
here.
Yes, sir.
Okay. Now,
Yes.
Yes.
so this will be 1 by 52, right?
1 by
Now we
52.
can cross check here probability of A2 intersection A3. This is same as probability of A2 into probability of A3. Since this is verified, I will say A2 and A3 are independent. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now, so let me take one example. Maybe that will help you to understand the case. Okay. So, there we are going to, in that example, we will be using the concept of independence. Okay. Suppose I'm saying there are two managers. Okay, manager X and manager Y. Okay. So I'm just writing the code. So suppose there are two managers. Okay, manager X and manager Y. So they are just they are just going to settle there is some, let's say, wage dispute among the workers. Okay, so they are going to settle that wage dispute among the workers. So I'm saying, let's say, probability of let's say, okay, let me define.
Your voice is down.
Let me
Your
define
mic will get
A as a, let me define as an event that manager X will settle the dispute, okay, among the workers. Okay? I will give you the probability. Let's say B will be event that, B is the event that manager Y will settle the dispute. Suppose probability that manager X will settle the dispute is, probability of A is, let's say I'm saying, no, let me take as a 3/7 for, and the probability of B is that 7/50, for example. So my question is, first question is, like, you have to find the probability, probability that neither settles the dispute. They both try independently. They both try to settle the dispute, independently, to settle the dispute. So you have to find the probability that neither settle the dispute. Okay, question is clear?
Yes, sir.
Okay,
Yes,
so
sir.
what do you mean by neither settle the dispute?
A complement
intersection of what?
union B
Complement.
complement.
Union.
Intersect.
Correct. So
Intersection.
basically, I'm talking about probability that I have to find A was, A failed to, manager X failed to settle the dispute, and B also failed to settle the dispute, right? And we know if A and B are independent, then A complement and B complement are also independent.
Yes, sir.
So from where
Yes,
can I
sir.
write probability of A complement into probability of B complement or not?
Yes, sir.
Yes, sir.
And we have A, then what will be the probability of A complement? 1 minus 3 by
4
7,
by
which is
7.
1 minus
4 by
3
by
7.
7.
And
by
probability of B complement will be 1 minus 7 by 15, that is 8 by 15.
8 by 7. 8
Yes.
by
8
15.
by 15, right? So this will be 4 by 7 into 8 by 15. Just we have to do the calculation.
32 divided by 105.
Okay, now this is clear, right? How we are going to use this part, right? Okay.
Yes, sir.
Yes.
Sir, could you please explain one again?
0.30.
Yeah. So question was, they both try independently to settle the dispute, right? There is no dependency while they are going to settle that dispute for wage or for, you can say, payment and all. So we know if A and B are independent, then A complement and B complement will also be independent. We have proved a bit few minutes before, right? So question, we have to find the probability that neither settles the dispute. So neither settles the dispute means A were failed and B were failed. Okay, or you can say A union B whole complement. Both are the same.
Got it, sir.
Got it? Yeah. Okay. All right. Yeah. this part is okay to all of you?
Yes, sir.
Okay. Yeah. Great.
Yes, sir. Yes, sir.
Okay. Fine. So I have taken this, examples and all. So let me come to very basic thing, which is very important. It's called, law of total probability. Okay. So to understand this law of total probability, so let me take examples for Okay, okay, suppose I'm saying there is a events, let's say E and F. And I'm saying they are mutually exclusive and exhaustive. What is the meaning of this mutually exclusive and exhaustive?
Mutually exclusive and they are independent.
Mutually
No, you
exclusive means
didn't
they have
see.
nothing
They
in
are
common.
disjoint.
They don't intersect.
They don't.
Independence and disjoints are two different things. Don't get confusion with this. Disjoint
Mutually,
means probability of A intersection B is 0, and independence means probability of A intersection B will be probability of A into probability of B.
They're like a subset of each other. So one could be subset, exclusive.
So I'm saying, suppose I have two events, let's say E and F. Okay. So I will say this events E and F are mutually exclusive and exhaustive events.
means they do not intersect, and when we add both of them, they cover the entire sample space.
Sample space.
Correct. Basically, I will say E union F is nothing but sample space, yes or no?
Yes.
Yes, sir.
And E intersection F will be
Null.
Empty.
5.
yeah. That is the meaning of this mutually exclusive and exhaustive event. Everyone will be agree with me or not? Okay. Suppose
Yes,
I'm
sir.
saying I have three events, let's say A1, A2, A3. And I'm saying this A1, A2, A3 are mutually exclusive and exhaustive. Then what is the meaning of this part?
They have nothing in common.
I'm saying not exclusive. I am also going to mention.
Say your voice is weak.
I'm also mentioning exhaustive event. A1,
Oh.
A2, A3 are mutually exclusive and exhaustive. Yeah, tell me. What should I write? Suppose
So you can write A union B union
okay,
C.
suppose I have three events A, B, C, for example. Okay. And I'm saying these three events are mutually exclusive and exhaustive events. Okay. So see,
A union B union C is sample space.
A, B, and C are mutually exclusive and exhaustive event. Maybe it will be clear in a minute. Okay. So what is the meaning of exclusive? A intersection B is 5, B intersection is 5, right? That means probability of intersection part is what? 0, right?
0.
And okay, so this means A union B union C is S.
Sample
Okay.
space.
Sample space. So if I will take probability of A union B union C, this will be probability of S
1.
will be, what is this part?
1.
Probability of A plus probability of
B.
B plus probability of C equal to 1 only.
Yes, sir.
Because
Yes.
rest probability will be 0 because they are exclusive events also. Now is it clear?
Yes, sir.
Right? So far so good?
Is there a possibility? Is there a possibility of something being exclusive but not exhaustive, something like that? I mean, I haven't thought about it. I'm just asking you.
As per my knowledge, I didn't see something like this. Possibility
Okay.
may be there, but I'm not sure about this.
Okay.
Okay. So I would be very clear about this. Okay. So
Sure.
this,
Thank
yeah,
you.
yeah, exhaustive, and also meaning of exhaustive means, the total, whatever the total number of possible outcomes of your random experiment is there, right? Total number of possible outcomes, right? So if
I
we are
understand.
talking, yeah. So that is something we are trying to understand. There might be cases, but I'm not, sure about this. But I will
Even
check.
I didn't. I cannot think about it, but I just asked you.
No worries, no, no, it's fine, it's fine. I will think a bit. If I will get something, I will let you. That's not a
All
problem.
right.
Okay.
Thank you.
Hello, sir.
Yes.
Sir, I have doubt in this.
Hmm.
There might be some events which are mutually exclusive, but their union is not sample space.
Their
Is there
union
any
is not.
case? Yeah.
Means they are
No, no.
not
So
exhaustive.
no, that's okay. So suppose you have two events A and B, right? You are saying they are
Mm-hmm.
exclusive. Okay. Then
Huh.
union will be sample space itself. Because union is what you are talking about. See, I will say A and B, right? Suppose something like that. So what A union B says, P of A plus P of B minus P of A intersection B, right? You are saying they are disjoint. That means this will be 0. So I'm talking about probability of A union B. If there is only two events, right? Then it will be P of A plus P of B, which is nothing but 1. Okay. If
But
there
if
is
we have
only,
more events and only two are
yeah,
considered,
yeah,
then
then it will be some cases. Suppose you are saying you have more events and two of them are not, two of them are disjoint, and but they all are mutually exclusive. But
Yes, yes, sir.
we have to think a bit. I mean, I'm not sure about whether this is possible or not. I need to cross check. Suppose we are saying two are not, and there might be something even something. Suppose these two are disjoint, right? Rest are something like this. Okay, that
Yes,
might
it
be,
sir.
can be because
can be, yeah.
if we consider ace and face cards, they have nothing in common. They are disjoint. Like
Yeah,
getting an
but
ace and
if we
face
are
card.
talking about lots of events, then we have to think. Okay, so
Yeah.
I will cross check for this part, but I mean, okay, I will cross check and do. I mean, accordingly, I will we can discuss in this part. Okay, this part is okay, right? This when I will say mutually exclusive and exhaustive. Yes or no?
Yes,
Right?
sir.
If this is
Yeah.
clear, so let's try to understand law of total probability. Okay, which is important. I will take one example also, so that it will be clear. So what is the case? Let me draw one Venn diagram. Suppose this is the Venn diagram. Before taking, in general, let me take two events. Suppose there is two things. Let's say this is F1 and this is F2. Okay, and this is all sample. There is one event. Let's say E. Okay, so I will take the example. So condition is, suppose this F1 and F2 are mutually exclusive and exhaustive events. Okay, then I'm talking about for any event E. Okay, I'm interested to know what is the probability of E. So to know the E, how I can find the E? First of all, just let me know whether you are agree with me or not. So when I will get the E, first of all, this part, this green part, yes or no? Means I'm saying E intersection F1 union of this red part. Then I will say E has been occurred, yes or no?
Yes, sir.
See, if I will take the union of red and green, then E will occur.
Yes, sir.
Okay,
Yeah.
for E, for why I wrote as a intersection F1, because if you see this whole part, right, this is F1, right? Inside this F1, this E is occurring, right? Similarly here inside this F2, E is occurring. Yes or no?
Yes, sir.
Okay, now if I will write the probability part, so probability of E will be, can I write probability of E intersection F1 plus probability of E intersection F2? Yes or no?
Yes, sir.
We are not going to
Yes.
write the intersection part of this and this, because that is we have considered as a disjoint, right? Now, multiplication rule. We have seen multiplication rule, right? So by using the multiplication rule, what was the case? Probability of E1, I mean E given F was, this was the conditional probability formula, right? What was the multiplication rule? Probability of E intersection F equal to probability of F into probability of E given F. Yes or no? This was the multiplication rule, right? By using the same case, can I write here probability of F1 into probability of E given F1 for this part? Yes or no?
Yes.
Plus this part probability of F2 into probability of E given F2. Yes or no? I mean, see, you can try to understand with intuition part here also. What is the probability of E intersection F1 when this green part will be there to occur this green part? I'm saying probability of F1 into, F1 has already occurred into probability that this given is F1 is given is F1 is already occurred. What is the probability that E part? Yes or no? To get this part, right? To another color, right? This to get this part, this green part. Okay. What is the thing? First, F1 should occur. We will be interested to know what is the probability of F1 or not, right? Yes or no?
Yes, sir.
Into F1 is there, then what is the probability for this green part? Right? That's something we are doing. Or else you can understand with this multiplication rule itself. Right? This intersection part I can write like this or not.
Yeah.
Yeah, correct, right? Are you getting me?
Yeah, understood.
Yes,
Right?
sir.
Yes. So this was for the two events, right? So basically, this was for two. When you have two, mutually exclusive and exhaustive event. Okay. Let me generalize it. I will take 10 examples. Okay. So let's say you have, some k events. Let's okay. Suppose this is F1, this is F2, this is Fk, and this is your another event E. Okay. So I'm interested to know what is the probability of E. First of all, to get the E, what is the case? E intersection F1, right? This should be there. Union of E intersection of F2, union and so on. Union of E intersection of Fk. Yes or no? Similarly, so probability of E will be probability of E intersection of F1 plus probability of E intersection of F2 plus so on. It will be probability of E intersection of Fk. Now, by using the multiplication rule, this I can write. Okay, can you tell me when this part will be occur? So first, this should be there, right? I would be interested to know this probability or not. Just try to think with intuition. So I would be interested. What is the probability of F1, right? Into I know I have already seen the F1 part. Then what is the probability for occurrence of this event T? Yes or no? This part.
Yes.
Right. So probability of similarly F2 into probability of E given F2. It will be clear more in a bit when I will take example. So it will be Fk into probability of E given Fk. So this part probability of E I can write summation I equal to 1 to k probability of Fi into probability of E given Fi. Previously we took one example with two events. Okay, let me take one example. Then I will maybe after that it will be clear. Suppose there is a case. Okay, there is a something. Like there is an insurance company believes that people can be, let's say we are going to divide the people in two parts. Let's say F, this is F, which is this one is F complement. So F is stand for, let's say, accident, uh, prone part, and this one non-accident. Okay. So why we are interested in, suppose there is an event E. That event E stand for, let's say, policy holder. Then they are going to, it's like this event is policy holder meeting with an accident in 1 year. Okay. So E will be that policy holder meeting with, I mean, they have an accident actually in 1 year. Okay. So let's say I have been given probability of F as a 0.2. Then what will the probability of F complement?
0.8.
0.8.
Suppose probability of E given F is there. Means they are, I mean, there is in accident prone area, something like that. And probability of E given F is 0.1. And probability of E given F complement is given as 0.5. So question is, what is the probability of E? To get, I mean, when policy holder meeting will meet with the accident in 1 year. So what is the possibility? This part, probability of E intersection F plus probability of E intersection F complement. Yes or no?
Yes, sir.
Yes, sir.
I hope it seems you are not getting. Let me take one more example after this. Okay, so what should I write this? Okay, so a trick here, probability of to find probability of intersection F, just use the conditional probability formula.
P into F dot P E slash F.
Correct. So from here I will get P probability of F into probability of E given F plus probability of F complement into probability of E given F complement. So just substitute all the respective values, you will get the answer. Let me take one more another example. Maybe that will give you a clear idea. Suppose I'm saying, let's say there are two fridges. I mean, you are, let's say this is fridge 1, this is fridge 2. I mean, you have entered in your kitchen and suppose there are two fridges. Okay. And I'm saying, so selection of the fridge, let's say, is, 3/4, and probability of selection of fridge 2, let's say 1/4. Why I'm saying, suppose this is the entrance door, and then okay, let's say there are 5 dark chocolates, 3 white chocolate in fridge 1, 2 dark chocolate, and 6 white chocolate in fridge 2. I mean, suppose you entered in the kitchen and there will be high probability to select the something from fridge 1, right? There will be some half probability also. I'm just taking, high chance for the selection of fridge 1. Okay, would you agree with me? Now it's fine.
Yes, sir.
Right. Suppose first question is, I'm saying you have to find the probability that you are going to, I mean, you are choosing a, white chocolate from fridge 2. That means what? Probability that W intersection F2, if W stands for white chocolate, yes or no?
Yes, sir.
So how will you compute? First, you will select the
F2.
F2, then F2 you have given, and U2, what is the probability for white chocolate? Do you agree with me? Yes or no?
Yes, sir.
So what is the probability of selecting F2?
1/4.
1/4.
And what about this?
It should be from multiplication rule.
Now that is the multiplication rule. What is the probability for this part? Means fridge 2 you have already selected here. Just try to understand here. Fridge 2 you have selected. What is the probability that white chocolate from fridge 2?
6/8.
8.
1/8.
3. 2/3.
Sorry?
6/8.
6/8.
6/8,
6/8.
right? In
Yeah.
fridge
Yes.
2 there are 6 white chocolate, right? It will be 6/8. You have to just solve this question, right? Now, suppose I'm saying probability that choosing a dark chocolate from, let's say, fridge 1. Then what I will do? First I will choose the fridge 1 into probability that suppose I have selected fridge 1, then what is the probability of dark chocolate? Yes or no? Basically, this is the multiplication rule itself. We are using multiplication rule. What is the probability of selecting fridge 1?
3/4.
And what is the probability of selecting dark chocolate from fridge 1?
5/8.
5/8, right? That will be answer. Yes or no? Let me draw the things again because it's on next page. So 3 are white. This is fridge 1. Now it will be clear, hopefully. 6 white, fridge 2, and probability of selecting fridge 1 was 3 by 4. Probability of fridge 2. See, it can be half. I just took because suppose. Now, question is probability that choosing a white chocolate only. Means I'm interested to choose the white chocolate. Now tell me, how should I proceed?
White and fridge 1 plus white and fridge 2.
Yes or no? Everyone would agree with me? So that means I'm
Yes.
interested. What is the probability
Yes.
that white chocolate and fridge 1 or white chocolate and fridge 2? Correct? These are the two cases. Yes or no? Now, how I will find this case? Probability of white chocolate and fridge 1. See, this one we have calculated from the this part, right? With the multiplication rule. Yes or no?
Yes, sir.
So how I can find this white chocolate and fridge 1? I will go
Same way.
for the fridge 1 into, suppose fridge 1 I have selected, and probability that white chocolate. Yes or no?
Yes, sir.
Plus, for this case, probability of fridge 2 into probability that fridge 2 fridge 2 is there. What is the probability that white chocolate? Now this is clear. Here we are using law of total probability. Are you able to relate?
Yes, sir.
Yes.
What is the probability of fridge 1?
3 by 4.
3 by
3
4.
by, what is this part?
3 by 8.
3 by
3 by 8.
Very good. And fridge 2, 1 by 4.
1 by 4.
And this part?
6 by 8.
6 by 8.
No, whatever the answer will be there, not going to solve. Okay, this is fine.
Yes, sir.
Okay, suppose I'm going to change the scenario. Now maybe given that you choose a white chocolate. This is given to you have selected white chocolate. You have to find the probability that it was from fridge 2. Are you getting? So what is the question? Given that you have chosen a white chocolate, what is the probability that it was from fridge 2? Yes or no? This is the question.
Yes, sir.
Okay. How will how should I write? Can I write by using the conditional probability formula F2 intersection W divide by probability of W?
Yes, sir.
Yes, sir.
This probability of W we have calculated in the numerator part.
Yeah.
What is this? How will you proceed for this F2 intersection W?
So we have already calculated above.
If we have calculated that, what is the meaning of this?
P of F2 multiplied by P of W given F2.
Yes or no?
Yes.
Right?
Yes.
This is probability of W. So
Yes, sir.
what was probability of W actually? So P of F2 into probability of W given F2, right? What was the W? P of F1 into probability of W given F1 plus P of F2 into probability of W given F2. This was the case or not? W we have computed from this formula. Yes or no?
Yes, sir.
Yes,
Right?
sir.
So this is called something. This is actually Bayes theorem. Okay. Okay. This is something called Bayes theorem. Means normally we are writing probability of Fi into probability of W given Fi. I mean this is done in the denominator part. I is equal to 1 to k. Let's say there are k. I mean instead of F1 and F2, there are, let's say, k fridges are there. Then you will write probability of Fi into probability of W given F. So this is something called Bayes. Is this fine? Means if you will come to this part, right? This when I took this part for F2 Fk. Okay. So if you come to this part, so what was the case? So there were some, suppose there are k events, right? So this was F1, this was F2, this was F of k, and this was, there was one event E. It shouldn't be outside this sample space actually. So this is the event T. Then initially we calculated from the law of total probability E, right? And we got summation I is equal to 1 to K probability of Fi into probability of E given Fi, right? This is something we have calculated. This is called law of total probability, right? Yes or no?
Yes.
And what is the Bayes theorem actually? This says, suppose E is already occurred, what is the probability that it's from F1? Okay. So by using the conditional probability formula, I will write probability of F1 intersection E divided by probability of E. So this probability of E is nothing but this part from the law of total probability. So what is the numerator part? I will write probability of F1 into probability of E given F1 divided by probability of. So this is something called Bayes rule. And let's say E has been occurred. What is the probability that it is from F3? Then probability of F3 given intersection E divided by probability of E. And what is this intersection part? I will write probability of F3 into probability of E given F3 divided by probability of. Okay, are you getting this part? Is this clear?
Yes, sir.
Okay, so this is something called Bayes theorem and law of total probability and all. Actually, we have seen this part. Okay, so if you want to do one, let me open one example from the activity. Maybe that will give us the idea. Okay, okay, let me go for the next one. Yeah, let's try to do the first part. Rest you can try on your own if concepts are clear to all of you. So question says company A produces 30% defective products. Company B produces 40% defective products. Company C produces 30% defective products. Now you will be able to relate. So there are three companies. Okay. A, B and C, right? Okay. There is one another event of defective products. Yes or no? Let's say D. Yes or no? Is this clear now? Are you able to relate?
Yes.
Right now. So question is, A produces 30% defective. So what is this mean? What is that event is given to you? And one more thing in the question, if you see, if choosing a company is an equally likely event, that means what? Means probability of A equal to probability of B equal to probability of C is 1/3. That is the meaning of
Yes, sir.
equally likely, right? Now this is given to us. What is the meaning of this? A produces 30% defective. A produces 30% defective. What is the meaning of this? How should I write in terms of notation?
Probability of defective given it is from A.
Yes or no?
Yes,
Yes.
sir.
Right? Because A
Yes.
produces, so it says A. What is the probability of defective? This is 30%, right? Yeah, I'm talking about this part, right?
Yes.
Okay. Now B produces 40% and C produces 30%. So B produces 40% defective, right? So that means what? Probability of B of being defective is 40% and C produces how much? 30% again, right? Yes or no? So question is, what is the probability that product chosen is not defective? So they ask probability of D complement, right? Not defective. So I can compute 1 minus probability of D. So let's try to compute first probability of D. Okay. So if you can relate probability of D, how you can compute probability of D? This is A, this is B, this is C. So this is for being defective. This is company A, this is B, this is C. How you can compute the defective product? Means product is defective and it is from company A,
Plus
or it is defective and it is from company B,
B.
or this is defective or it is from company
C.
C. Now how I can write this part? I can write I have selected company A and I'm interested to know what is the defective in A. Yes or no? Same for this probability of company B into defective in company B. Probability of company C into probability of defective in company C. Do you agree with me?
Yes, sir.
Now, so we have to just substitute the value 1 by 3 and this is I think 30 by 100. If I'm not wrong. This is 1 by 3. This is 40 by 100 plus 1 by 3 into 30 by 100. You have to do the just a calculation. Now, what's the role of Bayes theorem here? Suppose I'm changing the question. Suppose you have selected a product, chosen a product. Suppose that is defective. It is given to us a defective. What is probability that it is from company B? Right? So what I can write? Probability of B intersection D divided by probability of D. So probability of D we have calculated here. Right? What is the probability of B intersection D? It will be probability of B into probability of D given B divided by probability of D. So this part is nothing but this separate part, this 1 by 3 into 40 by 100 divided by this total. Yes or no? Yes. So this is called the Bayes theorem. Okay. So this, okay, so far so good. You got the idea, everyone? You get the yes, no, anything?
Yes, sir.
So your screen is not
Somewhat.
visible.
Yes, sir.
Yeah, I have stopped because I
Yes,
have
sir, we get the
explained.
idea.
Yeah, I have explained the more or less every concepts of week 8. So I'm assuming after this session you will solve the questions and you will come up with some your doubts from activity or practice in the upcoming session, which is going to happen on Sunday. One more thing. This upcoming Tuesday, there is a quiz to revision session which will be taken by Usha ma'am.
Usha ma'am. Yes,
Yeah,
sir.
and one more thing. Okay, so I'm thinking to release the solve the slides in advance for week 8. Will that be fine? Because
Yes, sir, yes, sir.
Tuesday Usha ma'am will revise the content, so you can just go through that slides on your own time. Will that be fine,
Yes,
right?
sir.
Yes,
Yes,
sir.
sir. That
Slide, sir.
will be good.
Okay, okay.
Sir, which slide, sir?
Solve the slides,
Sir,
right? Normally we are taking solve
Just
the
all.
session on
Okay,
Tuesday.
sir. The question containing the questions
But
and
this
solutions.
along with solution.
Okay,
See,
sir. Okay, sir.
but what is the case? This Tuesday, Usha ma'am is going to take quiz 2 session, so we will not be able to take solve the slides. So I'm thinking to release in advance. Okay. That
okay, sir.
solve the slides along with the solution part. Okay. Yeah.
Sir,
So yeah, doubt
sir.
is clear, right? This content is clear to all of you. You
Yeah.
got some. Okay. Yeah.
Yes,
All.
sir.
Yeah. Okay.
Yeah.
Fine.
Sir, send today's PDF.
Okay, as of now, I'm going to send in this chat box. But anyway,
Yes, sir.
I will share with the team, support team. They will upload on the portal as well under supplementary content. Okay, just give me a minute.
Okay,
I
sir.
will take a minute for me.
Okay, sir.
1 second. So I have sent in the chat. 1 second. There. Okay, can you check?
Yes, sir, we got it.
Okay, yeah, all right, yeah. Okay, then that's okay. Then
Sir,
we can wind up
sir,
the session. Okay?
hello.
Yes, Kunal.
Yes, sir. Thank you,
Sir,
sir.
Hmm?
before ending the session, can we just discuss one question? I'm like solving this more than 4 or 5 times and getting always a wrong answer.
From where it's?
It is from 8.1, question number 5.
Activity 8.1.
Yes.
Yeah, what is your doubt?
I'm like getting the wrong answer always. 0.3 difference.
Let me check. What is the activity 8.1? Maybe there is some mistake. 1 second. I'm just sharing my
Question based on
screen.
contingency table.
1 second. I'm just going to share my screen. This question you're talking about? Which question?
Yes, sir.
Which question? One, first,
Question number
second.
5. 5.
Question. So what is the conditional probability that person is a doctor given that person has defaulted in loan? So what is the given part? Person is defaulted in loan, right? So that means this yes part is given to you.
Yeah.
Means it will be how much? 500?
500.
Yes. Yes or no?
Yes, sir.
Yes, sir.
So what you have to do? 0.3 is the answer, right?
Yeah.
Yeah. So it's simple, right? So you can see what is the case? What is the given property? Person, sorry, person has defaulted in loan. That means this yes column is already given to you, right?
Yes.
That means what is your new sample space now? 500.
So how the sample space is 500? Actually, I'm not getting this.
Okay, let's do with the formula itself. If you're saying, I think you are not in the beginning of the session, that's why you are liking with that. No worries. So question is, see, probability that given that yes, and he is doctor, right? Yes or
Yes.
no? That means what? Probability of doctor and yes divided by probability of yes.
Yes.
What is the probability of doctor and yes? It will be 150 divided by
150.
what is the total now? 2000.
2000.
Yes or no? And what is the
Yes.
probability of y?
Y is 150 upon 2000.
Why 150? Y is this total, right? Yes, yes. There,
500.
for yes, there are 150 doctor, 300 teacher, and 50 yes safe, right? So there are
Okay,
total
okay. I got my
500.
mistake.
Yeah. Okay. Now which it will be 150 divided by 500. Not 150. Yeah, 150 divided by 500, right? Which is 0.3. Okay.
Yes, sir.
I'm just taking the whole doctors.
No, no. Yeah, just that's why I'm saying just define the event. It will be clear enough. Okay. Okay. Yeah. Okay. Okay then. Thank you guys. Okay. Bye.
Thank you, sir.
Thank you. Bye. Good night.
Thank you, sir. Good night, sir.
Thank you.
Sir.